Welcome to another video. We are given two integers a and b, neither of which is a multiple of 3. We're asked to prove that a to the sixth minus b to the sixth is divisible by 9. This is a pretty easy problem, but it becomes very crazy if you do not know Euler's totient function. Even though it is the easiest path to it, unless you've taken some number theory classes, you may not have ever heard of Euler's totient function, and you might have to do some algebra. So I'm going to solve this question using both the totient function and just basic number theory algebra. Let's get into the video. So the first thing you want to consider is the set of conditions that were provided. You were given that a and b are integers and they are not multiples of 3. Now they want you to show that the difference of these 6 is a multiple of 9. Now, what I would think of is, why would they choose the numbers 3, 6, and 9? In particular, why 6? Why is it the 6th power? Well, when you're used to number theory, you'll understand that Euler's totient function says that if you pick two numbers that are relatively prime, okay? So let's say we pick the number 10 and the number 3. We know that 3 and 10 are relatively prime. They have no common factors other than 1. Now, if you can find the totient of 10, now what does that mean? It is the number of integers less than 10 that are relatively prime to 10. Now it sounds complicated. If you list all the integers, look, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Which of these numbers are relatively prime to 10? Well, we got 7. We know that 3 is relatively prime to 10. We know 9 is relatively prime to 10. We know 1 is relatively, well, you always include 1 in number theory as relatively prime. Now, look at this. It doesn't mean 1 is prime, it's just relatively prime. They have no other common factor apart from 1. So we got 1, 2, 3, 4. There are 4 numbers less than 10 that have no common factor with 10. So we can say that the totient of 10 is 4. So this is Euler's totient function, or Euler's theorem. It is that if you take any number that is relatively prime to 10, now it doesn't need to be one of these numbers, any other number you pick. Let's say you pick the number 11 and you raise 11 to the 4th power, because the 4th power, 4 is the totient of 10. You raise it to this power. Your answer is going to be 1 mod 10. What it means is that the remainder is going to be 1 whenever you divide it by 10. Any number. This one too. 3 raised to power 4 will leave a remainder of 1 when you divide by 10. 3 to the 4th is 81. Pick any number. Whatever number you pick, as long as it is relatively prime to 10 and you raise it to the totient of 4, it will always be 1 mod 10. In another video, I'm going to do the proof of this totient function, but today I just want to use it. So that's what we're going to use. So now the numbers in this question are 9 and 6. So you want to say, could it be something similar? Can we find a remainder? Yes, because if you look at the number 9, the totient of 9 is actually 6. Look, let's start from here. All numbers less than 9 that are relatively prime to 9, I'm going to strike them through. 1, 2, 3, 4, 5, 6. All those 6 numbers have a common factor of just 1 with 9. So the totient of 9 is 6. That's if you go by way of counting. You can also use the formula. I'll talk about all of those in the next video. So clearly, if you're used to number theory problems, you know that the totient of 9 is 6, okay? Are we good? The totient of 4 is 2. The totient of 10 is 4. The totient of 100 is 40. Okay, you get used to these things. The totient of any prime number is the prime number minus 1, which makes sense. So here, we're going to say the totient of 9 is equal to 6. Since A is relatively prime to 9. How do we know it's relatively prime to 9? Well, they said it is not divisible by 3. Any number that's not divisible by 3 is absolutely relatively prime to 9, because 9 doesn't even have any other common factor. So it's either 3 or 9. Okay, so since A is relatively prime to 9, as it is not a multiple of 3, then by Euler, I'm just repeating it, I know that A to the 6th, which is the totient, A to the 6th is equal to A to the totient of 9, which is congruent to 1 mod 9. Okay, I know I did a lot of explaining, but this is the whole idea. A to the 6th is 1 mod 9. So it means you can say A to the 6th, if you move this one over here, minus 1 is congruent to 0 mod 9. Similarly, the same thing is true for B. We say B to the 6th minus 1 will be congruent to 0 mod 9. Okay, so with these two facts established based on this Euler's totient function, we can say, why don't we subtract this from this, okay? And we're done. So if we subtract this from this, we say that A to the 6th minus 1 minus B to the 6th minus 1 is congruent to 0 mod 9. Okay, as you can see, this is the same thing as A to the 6th minus 1 minus B to the 6th plus 1, which is congruent to 0 mod 9. And looking at these two cancel each other out. A to the 6th minus B to the 6th is congruent to 0 mod 9. Therefore, 9 divides A to the 6th minus B to the 6th. We're done. Now, we're just going to do some algebra to do this problem. Note, because A and B are not divisible by 3, any number that's not divisible by 3 is 1 more than a multiple of 3 or 1 less than a multiple of 3. Any number. Pick the number 4. It's not divisible by 3. Well, it is a multiple of 3 plus 1. Pick the number 20. 20 is a multiple of 3 minus 1, right? So any number not divisible by 3 is 3k plus 1 or 3k minus 1. A equals 3k plus 1 or 3k minus 1, where k is an integer, okay? Yes, is an integer. Now, also, B is, let's say, IJKL, 3L plus 1 or 3L minus 1, right? Where L is also an integer. Okay, so we can actually say that A equals 3k plus or minus 1. That's the short form of it. And we can find A squared. If you square A, what are we going to get? We're going to get, if we square this, let's square this. This is going to be 9k squared plus or minus 6k. Now when you square the last one, whatever happens is going to be plus 1, right? And a short form of this is we can actually, because see, our aim is to get something that's a multiple of 9, so, and we're still going to raise this to more powers, right? So what we should do is we should rewrite this. Okay, so I'm going to rewrite this and say that 9k squared plus 6k plus 1 is the same thing as 3 times 3k squared plus or minus 2k plus 1. Now this is another integer, right? Because it's another integer, I can represent it as, let's say, 3m plus 1, where m is equal to this, okay? Also an integer. M is representing this. I'm not going to write that. Similarly, we can say that b squared is equal to 3n plus 1. So now, all we have to do is find a to the 6th. Well, we know that a to the 6th is a squared cubed, which is going to be this guy cubed, 3m plus 1 cubed. Whew. Is there a way we can answer that in this tiny space here? Yes, I think we can. Let's do b to the 6th also. b to the 6th is going to be b squared cubed, which is 3n plus 1 cubed. Well, we're going to end up with a cubed. A to the 6th will be, if you cube this using Pascal's triangle or binomial expansion, we know this is going to be 3m cubed is going to be 27m cubed. That's the first term. 27m cubed is the first thing. The second thing is going to be 1331. 3 times the square of this, that's again 27m squared plus 27m squared. Then the next one is going to be 3 times 3m. That's going to be 9m plus 9m. And then the last one is going to be just 1. Ooh. And then we have b to the 6th rather. So we do b to the 6th is going to be 27n cubed plus 27n squared plus 9n plus 1. Now if we do the subtraction, a to the 6th minus b to the 6th, it's going to be this minus this minus this. You'll end up with, we can factor out 9. Let's just factor out 9 from everything. Well, this is going to cancel this. So you have 9 times, this is going to be 3m cubed minus 3n cubed plus 3m squared minus 3n squared. And then you have plus m minus n. I hope the camera captures that. By the way, this is divisible by 9. This must be divisible by 9, and that's it. So, a to the 6th minus b to the 6th is a multiple of 9. Therefore, 9 divides a to the 6th minus b to the 6th. Done. Whichever way you want to go, this works. The only good thing you should do here is make this substitution, because if you don't, your work is going to go poof. You don't want it to go poof. Never stop learning. Those who stop learning, stop living. Bye-bye.